Async Await looks simple, but internally, JavaScript is creating promise objects, pausing functions, storing hidden callbacks, and later restoring execution through the event loop. All automatically. JavaScript runs on a single thread, so if it waited normally for slow operations like API requests, database calls, or timers, the entire application would freeze. So JavaScript needed a non-blocking system. That system was promises. When new promise runs, JavaScript immediately creates a promise object. It stores the current state, the future result, and two internal callback lists waiting for completion. At first, the promise state is pending. No result exists yet, and no handlers are registered. Next, the executor function runs immediately. JavaScript provides two special callbacks, resolve and reject. When setTimeout registers, JavaScript does not pause execution. The timer starts waiting outside the JavaScript engine, while JavaScript continues running the next lines immediately. So when then and catch execute, their handlers get registered into the promise's internal reaction lists. If the promise is still pending, JavaScript stores those handlers internally, waiting for the promise to complete. When resolve executes, the promise changes from pending to fulfilled and stores the final result internally. Then JavaScript takes all registered fulfillment handlers, moves them into the Microtask queue, and executes them one by one. But there's another important behavior. A promise can actually finish before handlers are registered. In that case, the promise still remembers its final result internally. So even if then is attached later, JavaScript can still execute the callback correctly. If the promise is already fulfilled before then is attached, JavaScript skips storing the handler and directly schedules the callback into the Microtask queue instead. This is why promises are reliable for asynchronous programming. And this exact promise system is what powers async and await. Because when an async function is called, JavaScript immediately creates another hidden promise. This promise represents the future completion of the entire async function. The important thing is, this hidden async function promise is separate from the promise being awaited. One promise tracks the async operation itself, and the other promise tracks the completion of the entire async function. When await sees a pending promise, execution cannot continue yet, so JavaScript creates a continuation callback. This callback contains the remaining code that should continue later. Then JavaScript stores it inside the promise. Now the async function pauses. But JavaScript itself does not pause. Only this function is suspended. The JavaScript thread is now free to continue other work. Later, when the async operation finishes, the promise becomes fulfilled. JavaScript now moves the stored continuation callback into the Microtask queue. The event loop checks whether the call stack is empty. And microtasks always run before normal callbacks. So JavaScript restores the async function, and execution continues exactly where it paused before. So Async Await is not magic. It's built on top of promises, the event loop, and the Microtask queue. Async functions create hidden promise objects. Await creates continuation callbacks. Those callbacks wait inside the promise until the async operation finishes. Then the event loop restores execution through the Microtask queue. And once you understand this execution flow, async JavaScript suddenly becomes predictable. Subscribe for more visual breakdowns of how JavaScript and backend systems actually work.